Hey, all you clever little cupcakes. Today we are going to be solving the pH of a strong base. Now, typically, when we solve the pH of a substance, we're using the equation pH equals the negative log of the concentration of H3O+. But when we're working with strong bases, there's no H3O+ for us to be dealing with. We're working with hydroxide. So what we're going to do is use a second equation that's called the POH, and it equals the negative log of the concentration of hydroxide. Once we have this POH, we're then going to use one more equation to loop back around to pH by saying that our pH plus our POH equals 14. And you're going to get to see how this is done because we're going to do an example. In our example, you have been provided with a solution of sodium hydroxide. Yeah, I know, what a vanilla pick for a base, but it's the base that I went ahead and selected, so here we go. And it's 0.0008 moles per liter. And we can see what happens if we dissolve sodium hydroxide in water, because if we start off with a sodium hydroxide solid and put it in water, it's going to become a sodium ion, and it's going to become a hydroxide ion. And hopefully everyone out there recognizes that this is a 1:1:1 ratio. A single sodium hydroxide molecule produces one hydroxide. So it's 1:1. That means our concentration of OH minus is going to equal 0.0008 moles per liter. Maybe I could have written that in scientific notation, but I'll do that for the next one. We can take this concentration of hydroxide, fill this into our POH is equal to the negative log of this concentration that we have. We're going to get a POH equal to 2.1. All right, now we've got our POH. We're going to fill that back into this equation right here, our pH plus POH, and we're going to get pH plus 2.1 equals 14. Subtract 2.1 from both sides, subtract 2.1, subtract 2.1, and we get a final answer of pH equals 11.9, just like that. This answer makes sense. We know that pHs above 7 are basic, so we should not have gotten a very low value for pH, and we've successfully been given a sample of sodium hydroxide and converted that into a pH. Let's go ahead and do one more example. I'll move this up, and this time we're going to have, for example number 2, maybe a bit more of a fun base. Example number 2 is going to be a concentration of magnesium hydroxide, and it's equal to, we're going with scientific notation this time, 3.2 times 10 to the negative 5 moles per liter. Unlike the sodium hydroxide, this is not a 1:1 ratio. I'm hoping that you're looking at this, and now you're feeling all good about yourself, and magnesium hydroxide is going to donate 2 hydroxides. Now I can write this out and show my work, that magnesium hydroxide, if we dissolve it in water, is going to become a magnesium ion, but it's going to produce 2 hydroxides. As long as you recognize that it produces 2 hydroxides, you won't have to write this all out. In order to get our concentration of hydroxide, you're going to have to take this initial concentration, the 3.2 times 10 to the negative 5, and multiply it by 2, because it's doubled. This is going to give us a concentration of hydroxide equal to 6.4 times 10 to the negative 5 moles per liter. Now we can fill this into our POH equation. POH is equal to the negative log of the concentration of our hydroxide, which was 6.4 times 10 to the negative 5, close my bracket. I don't have to use square brackets anymore. This is just a number. Square brackets means concentration. It tells you what units you need to be in. Our pOH is going to equal 4.19. To turn this into pH, we go back to our equation. pH plus pOH equals 14. pH plus 4.19 equals 14. We bring the 4.19 to the other side, and we get our final answer of pH equals 9.81. And that's how we can get the pH of a strong base. Thank you very much, and I hope to see you all next time.